Good afternoon, class. We are looking at exam 2 review covering chapter 3 from section 3.2 to 3.5. Find an equation of a tangent line to the graph of the function f of x equals x squared minus 3x minus 1 at x equals. To find an equation of a line, you need two things. You need the slope and you need a pair. To find the slope, you differentiate. You get 2x minus 3. If you plug in x equals 4 into the original function, you get the pair. So 4 squared minus 3 times 4 minus 1 gives you 3. And if you plug it into the f prime, the derivative function, 2 times 4 minus 3 is 5, that is the slope. So y minus y1 equals m times x minus x of 1, which means y minus 3 equals 5x minus 4, and we distribute. We get y equals 5x minus 17. Of course, you can put the pair, it works, which means this process is right, has got nothing to do with the slope. The second part of example 11 is to differentiate this, and we're going to remind everybody that square root of x is x to the power of 1/2. We also remind everybody a to the power of m times a to the power of n is a to the power of n plus n. This is the product rule for the exponentials. This one, where we have no exponent, that means x to the power of 1, everybody. This means x to the power of 1. When you multiply it here, 1 and 1/2, they add up to 3/2. This is 5x. So we have x to the power of 3/2 plus 5x minus 2. And to differentiate this, we get 3/2 x to the power of 3/2 minus 1, which is 1/2. And this is, of course, 5. We put it back in the same format. Recall square root of x is x to the power of 1/2. So we put this in the same format we got. 3/2 square root of x plus 5 is the final answer. To differentiate this, we are going to again change the square root of x to x to the power of 1/2, and we put a raised dot in between, meaning we are using the product rule. So I'm going to call this f times g, the product rule. F prime is 1/2 x to the power of 1/2 minus 1 or negative 1/2 times g e to the power of x plus g prime is itself e to the power of x times f x to the power of 1/2. And this is the extent of the calculus steps. Now we are going to use algebraic steps to finish the job. Number one, this is to the power of negative 1/2. We take it down, make it to the power of positive 1/2. We are looking at negative exponential rule, and of course becomes square root of x. And this x to the power of 1/2 is square root of x. So we rewrite this. We would be done. However, the reason I want to, continue with this, because later on we will look at the methodology that we need to set this equal to 0 and find extrema. So how do we do that? We want to take a common factor between the two. We notice this has the denominator 2 square root of x. If we multiply and divide by 2 square root of x, now we can see the common denominator of 2 square root of x. When we multiply these two, understand that if you extend this fraction bar, you have e to the power of x times square root of x times 2 times square root of x, which means this one really becomes 2x e to the power of x. And so we are going to rewrite this one, and then 2x e to the power of x over 2 square root of x as 1 over 2 square root of x e to the power of x, and we have 2x left. These two are identical, everybody. And so I can take them out. If I take this out as a common factor, this results in 1, this results in 2x. And that's the final answer. Y equals e to the power of x over 1 plus x, and we are going to write f over g, meaning we are going to use the quotient rule on that. Therefore, I'm going to need f prime g minus g prime f over g squared. So f prime is e to the power of x itself times g, just the denominator, minus g prime. The denominator gives us just 1, so minus 1 times f, which is e to the power of x, and then over g squared. Just write the denominator and square that. So what happens is that e to the power of x, e to the power of x times x minus e to the power of x, and these two cancel each other. So the denominator doesn't change, and the numerator is e to the power of x times x. We put the x in front. So the final answer is x e to the power of x over 1 plus x quantity squared. That would be the final answer, everybody. We are going to move on, and y is 5x times 3x minus 2 to the power of 4. First, I want to mention that this number is the coefficient that will carry over. You have two choices. You can keep it as part of x or just put it out. However, when this number is a simple number to deal with, you can just treat this as part of x, and therefore this is your function f. This is your function g. If this number is extremely large or extremely small or decimal or fraction, then you want to keep it out. We're going to discuss that further in a moment. But for now, f times g, we are going to go with f prime g plus g prime f. So f prime is 5 times g, 3x minus 2 to the power of 4, plus g prime. Now, g prime uses the extended power rule n, so plus 4, g of x to the power of n minus 1, this thing to the power of 3, and then times the derivative of the inside, which is 3, and going back to the product rule, g prime f times 5x. We're done as far as calculus is concerned. In fact, I'm going to put the asterisk next to it. That means that's the extent of the calculus. Now, of course, we're going to finish it off with algebraic technique. So this doesn't change. This one, I'm going to write it 4 times 3 times 5x, 60x. So it becomes ready for the next step, which is factoring. The common factor is 5 as well as 3x minus 2. This one has exponent 4. This has exponent 3. So we go this with the smaller of the two and becomes 5 times 3x minus 2 cubed. So if I divide this one by this one, I just get 3x minus 2. And if I divide 60x by 5, because this goes away, I get 12x. Now I can combine these two. So this doesn't change. This doesn't change. This becomes 15x minus 2, and we are done. As I mentioned, what happens if this number 5 is huge? Notice, first and foremost, that this number 5 just carried over. So you could take it out and now say this is f times g. F is just x. So when you differentiate that, you get just 1 instead of 5. Then everything else is the same, and 5x is x. Notice x gives you 1 times 3x minus 2 to the power of 4. This thing is identical to that one. Times 5x would be times x. The 5 carries. So which one is easier? That's your choice. Makes no difference in this case because 5 is an easy enough. Part B, y is 1 over 7x squared minus x to the power of 4. If you have a fractional format where the numerator is any number, you can just bring this up to the power of -4 and use the extended power rule on that. You don't have to use the quotient rule. So speaking of that, y prime would be -4 times the same thing to the power of -5 because -4 minus 1 gives you -5. And then the derivative of the inside is simply 14x minus 1. To finalize that, we're going to take this down. This is an algebraic step and raise it to the power of +5. This is following the negative exponential rules. So -4 times 14x minus 1 remains up. 7x squared minus x to the power of -5 goes down, becomes 7x squared minus x with the positive exponent 5. Y is x over 2x minus 1 to the power of 4. And to differentiate that, we are going to rewrite this as f over g. Therefore, we are telling the reader that we are going to use the quotient rule. F prime g minus g prime f over g squared. So f prime is 1. Times g, which is 2x minus 1 to the power of 4. Minus g prime. Now g prime uses the extended power rule. 4 times 2x minus 1 cubed times the derivative of the inside 2. And now times f, which is x, over the g squared, just this one to the second power. That means 4 times 2 is 8. Notice we do have, I'm going to write this, then I'm going to erase it. We do have f prime g minus this entire thing is g prime f, and the bottom is g squared. Of course, I'm going to simplify it. And so I'm going to erase my work, but this is it. You're done with calculus here. Now we are going to simplify. That means we're going to use our algebraic techniques. So that means we notice between these two, 2x minus 1 cubed is in common. So if I divide this one by this one, just gives me 2x minus 1. And if I divide this one by it, gives me -4 times 2 times x, which is -8x. So what do we do? It's very simple. Number one, this one is 2x minus 1 cubed. This is 2x minus 1 to the power of 8. This goes away, and 8 minus 3 becomes 5. So 3 of them goes away. This becomes 5. And then we are left with the brackets in the numerator. So the bottom is 2x minus 1 to the power of 5. The brackets, these two add up to -6x. We get -6x minus 1. And that's the final answer for y prime. Again, we are looking at a case where we have a fractional format and the numerator is just a number. Therefore, we don't have to use the quotient rule. Rather, we rewrite it in this format. As you can see, of course, this one is to the power of 1/2, right? Square root of x to the power of 1/2, the same thing here. And you bring it up, you make a negative 1/2 according to the negative exponential rule. And now you've made it ready for the extended power rule. So y prime is 4 times negative 1/2 times the same thing to the power of, you're going to subtract 1 makes it negative 3/2. So again, negative 1/2 minus 1. And then the derivative of the inside, we are looking at the chain rule. So that means 2x. And that is the extent of the calculus. So to finalize that, we are going to multiply these two. We get negative 2 times this one, we get negative 4x. And this one has the exponent negative. Remember, again, with the negative exponential, we're going to take it down, make it positive 3/2. And we want to put it back in the same format. Remember, to the power of 1/2, that means square root. So you can say this is minus 4x over the square root of x squared plus 3 to the power of 3. Or you can put this exponent outside the radical sign, makes no difference. What about this one? Y equals cosine 3t to the power of 4, reminding you the derivative of sine is cosine, the derivative of cosine is negative sine. And then if you happen to have a function of x, for example, here we would add du dx, or in this case, du dx or g prime of x. So in order not to make a mistake, the way I approach that, I hope you remember it, I say, okay, I'm going to say cosine and I'm going to stop. That will help me see what my next step is. Cosine, the derivative is negative sine. I'm going to write negative sine. And again, remember, any trigonometric function or sinusoidal function without the argument is meaningless. You can't do that. So you're going to put the same argument. And by the chain rule, the u dx, in this case, the u dt, because t is the independent variable, 12t cubed, and you put that in front. So y prime is negative 12t cubed, sine of 3t to the power of 4 as the final answer. We're going to differentiate the expression y equals x squared plus 4x over x to the power of 6. And anytime you have a case like that, you want to ask yourself, can I simplify it first? And the answer is yes, meaning this is x, this is 4, and you're dealing with x plus 4 to the power of 6, which means no need to do the quotient. That's the idea. So we are going to use the extended power rule, everybody. So we get y prime equals 6, the same thing to the power of 5, times the derivative of the inside 1, which makes it y prime equals 6 times x plus 4 to the power of 5. In this case, we have to use the extended power rule in conjunction with the chain rule. So the extended power rule, so we need the 5. Then we need the same thing to the power of 4. So the same expression, 2x plus 3 over x minus 8 to the power of 5 minus 1 over 4. And now we need the derivative of the inside, which means we are going to write it as f over g and use the quotient rule, which means now f prime g minus g prime f over g squared. F prime is 2 times gx minus 8 minus g prime, the derivative of the bottom is 1, times the numerator 2x plus 3. And then you put the denominator x minus 8, g squared. And you're done with the calculus part. And we are going to continue by taking the algebraic technique. So this is 2x minus 16 minus 2x minus 3 is to cancel each other, is to add up to negative 19. Now you can go to the final step, but I want to do it in 2 steps to become clear what we are dealing with. So in the numerator, we have 5, 2x plus 3 to the power of 4, negative 19. In the denominator, we have x minus 8 to the power of 4, as well as x minus 8 squared. So this part is 5, 2x plus 3 to the power of 4 at top, x minus 8 to the power of 4 at the bottom. And this one, negative 19 in the numerator, x minus 8 quantity squared at the bottom. So the denominator first is x minus 8 to the power of 4 plus 2. And the numerator is 5 times negative 19, which is negative 95, times 2x plus 3 to the power of 4. So it's very simple, everybody. All right, we're dealing with a bunch of exponentials, and I remind everybody that the derivative of e to the power of x is itself. The derivative of e to the power of kx is k e to the power of x. The derivative of e to the power of g of x is itself times g prime. If we have some base, a to the power of x, that is different than e, then the answer is itself times natural log of that base. Sometimes we use a, sometimes we use b. And the derivative of tan x, for example, is secant squared. So right here, I say the answer is itself. Then times the derivative of tan x, and I put it in front. I do the same thing here. The answer is itself. Then times the derivative of tan x, which is secant squared, and you don't have to make any changes. What happens here is that, again, you're right, it's an exponential. The answer is itself. Then you look at the base is not e, so you need to write natural log of the base. So ln 3, and you rewrite it and you're done. Whereas here, you really follow that one. Again, you just write the function because it's an exponential format. Then you look at the base. Since the base is not e, you need natural log of that. And then f prime of x, because this is a function of x, you need the derivative of 30x squared, which is 60x. And you just rewrite it. The methodology is normally to put these two together in the following manner. 60x times ln 5, put it in front, 5 to the power of 30x squared. That's how we do that. We've done these questions in during the lecture notes, during the lecture, so you have it in your lecture notes. Observations show that the length L in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age, T in days by the function W equals 3 plus 0.21 T. How long is the tiger when it's 100 days? Well, we're going to look at it just the way it is. This is elementary algebra. So you plug in 100 here. This has 2 decimals. This has 2 zeros. They cancel each other. 1 times 21. 21 and 3, they add up to 24 kilograms. If you put the 24 here, W is the weight. And you get L of 24 is 0.25, 24 to the power of 2.6. You put it into a calculator. You get 969.369, and that is in millimeters. And again, reminding you that 1,000 millimeters is 1 meter. This is close to 1 meter. So that's elementary algebra. At what rate is the length increasing when it's 100 days old? Now, rate, 1 point in time, that means differentiation at the length with respect to time, so we want the LDT. In Leibniz's notation, dy dt is dy du dt. So what happens here that from y to t, the intermediate variable is u, and here from L to t, the intermediate variable is w, so dl dw dw dt. So what is dl dw? 0.25 times 2.6, w to the power of 1.6. So 0.25, the exponent becomes a coefficient, and then the exponent goes down by. So that's dl dw. What is dw dt? Simply 0.21. So dw dt is just 0.20. We can multiply the 3 numbers, 0.25, 2.6, and 0.21, and we get 0.1365 w to the power of 1.6. We could replace the w with this, and becomes a function of t, and replace the t with 100 to get to the answer. However, in the previous part, we did get the weight when the tiger is 100 days old, so we can replace it with 24, and we have the answer. 22.0532, the change in length over change in time, millimeters per day. The units, just you can easily get it from the given question. The second method is to replace the W with this and find their composite function. For part A, if you plug in 100 here, you get 0.25 times 3 plus 0.21 times the t, which is 100 to the power of 2.6, and it will give you exactly the same number that we got in part A of the question. As far as differentiation is concerned, the LDT or L prime of t, 0.25 times 2.6, the same thing to the power of 1.6 by the chain rule times 0.21. A quick recap, 0.25 times the exponent 2.6 times the same thing to the power of 2.6 minus 1.6 by the chain rule times the derivative of the inside. If you multiply these 3 numbers, we get 0.1365. And notice these 2 are identical, everybody. We could have changed the W here and we would have gotten this one. And of course, if you replace the T with 100 here, you must get the same answer that we got here, 22.0532 millimeters per day. And of course, because it's positive, it means increasing. In many cases, they would ask the change, and that means increasing when it's positive. The amount of glass recycled in a community is G of P equals the square root of 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that T years from now, the population of a community will be P of T equals 4.4 plus 0.1 T squared thousands. How many tons of glass are expected to be recycled 4 years from now? Well, if you replace the T with 4 here, you get 4 squared, which is 16. Times 0.1, which is 1.6 with 4.4 gives you 6,000 people. If you put the number 6 in here, 6 squared is 36 times 0.5. 18 plus 7, 25. Square root of 25 is 5 tons of glass. So this is elementary algebra. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. By the way, you should always include units. So we want dg dt. According to Leibniz's notation, what is the intermediate variable here? dy dt was dy du du dt. Here's from g to t. In between we have p, so dg dp dp dt. Again, following the same format, going from g to t, what's in between is p. So what is dg dp? You have to change this so it becomes ready for the extended power rule. So you raise this to the power of 1/2. And now dg dp, 1/2, same thing to the power of 1/2 minus 1 or negative 1/2 times the derivative of the inside. With respect to p is 0.5 times 2p of p. So again, 1/2, same thing to the power of 1/2 minus 1. The derivative of the inside, 0.5 times 2p of p. That's dg dp, everybody. What is dp dt? 0.1 times 2t, so 0.2t. And since t is 4, p was found to be 6 from the previous part. We have two choices. We can use those numbers, or we can change the p, that means p of t, to 4.4.1 t squared and do the math. There is no need to do that. This will do the job. So all you have to do is simplify this expression. Again, reminding you that this part is just this part. And this part is this entire brackets. So how do we put it together? A fraction bar. In the numerator, you have 1, you have p, and you have 0.2t, so you have 0.2 pt. In the denominator, you have 2, and this guy with a negative 1/2 goes down, positive 1/2 becomes the denominator, and 0.5 p squared plus 7 to the power of positive 1/2 is the square root. Again, we are keeping p at 6, t at 4. So if I replace the p with 6 for this one, we've already done that. When we change it to 6, what do we get? We get 5. So this is 5. So this is 2 times 5. And this is 0.2 times 6 times 4. So 2 times 5, the denominator is 10. The numerator is 0.2 times 6 times 4 is 0.48. It's 4.8, which is divided by 10 is 0.48. Now, dg dt, the change in g over the change in t, tons of glass per year. So what does it mean? 4 years from now, the amount of glass recycled is increasing. Why increasing? This has a positive sign. At the rate of 0.48 tons of glass per year.